All right, what we're going to be talking today about is graphing linear inequalities. And these are when we're going to have two variables sometimes. And so we've done one variables, and remember it was either open circle to the right, open circle to the left, closed circle to the right, or closed circle to the left. Well, a closed circle is kind of a solid line. So it's a solid line is like a full line, so a closed circle. And then an open circle that we used to have was just the greater than or less than sign. So when you see this line underneath, that should help remember that it should be, a closed line. And then there's times the shade above. Shading above is when it's bigger. And so when y is greater than, or when y is greater than or equal to, you're going to shade above. It can be confusing because it's not the other thing you look at. You look to see when y is big or small. So shading below is when y is less than. So for all problems, the process is the first step you need to do is you need to try and solve each equation for y. A lot of times it's going to be there already, so that's good. The second thing you have to do is you're going to have to flip the inequality if you divide, and that's the step that a lot of people are going to forget. Remember that rule that if you divide by a negative, you flip the inequality. So if I had a problem like this, to get rid of that negative 2y, I have to divide everything by negative 2. And because I just divided, I have to flip it, which now means I'm going to shade below. So you need to be careful on those. All right. So let's go ahead and focus in on these first so that you get an idea of what it looks like. We're just doing the basic parent graphs of each of these when it's just y is x. And so that's right here. And then this is just 1 over 1. So it's just this diagonal line. And since there's no line underneath this, I know that this is going to be a dashed or a dotted line. And it says y is greater than. Now, when it's greater than, what matters is the y. So you'll need to look at your y-intercept, and I'm going to shade above the y-intercept. So above the y-intercept is there. So that means this is my shaded region. Okay, same thing here. I have a 0 for my b. But it's this perfectly straight line. This is what all of them are going to be because they're the parent graph. The difference here is this, I have this underline. So remember when you have that underline, that equal to sign, that means it includes that. So it's a solid line. And again, it's greater than, so I shade above where y is. And that happens to be here again. All right, scooting over to the left too. So here, same equation. This time though, it's not underlined, so it's going to be a dotted line. But you see it's less than. So I go to my y-axis, I shade less than that, below that. And so this time, this is what below looks like. One thing that people are going to want to do is they're going to want to talk about it being left and right. The only time you're ever going to do left and right is when it's an x equation. All the other times it's going to be above or below. Not left, right. Okay. And then here, same idea, but since it's underlined, it should be a solid line. And less than, I shade below the y-axis, the y-intercept actually. And so there it is. All right, what we're going to do now is we're going to do the same thing, except now I have a negative line, a negative slope, which means that it's going to go down 1 over 1. And it's a dotted line because there's nothing underneath. So it goes this way. Now, the reason I wanted to do these two is because I wanted you to see that depending on the slope of the line is where you shade. So that's why it's important never to shade left or right. You always shade up or down. And so I'm supposed to be greater, so I shade above the y-intercept. And so for this one, it's on this side. Same thing over here, but this time it's a solid line. And I'm supposed to shade above, so I shade above the y-axis, the y-intercept. And so that's it. So on these two, the difference is the slope. And so with a different slope, that's going to have to be where you graph it based on our shade, based on where it's up above the y-intercept. Okay. For the next two, so it's kind of off center, but it goes here. That's fine. So negative x and dotted line, so same thing. But this one says less. So I'm going to go below the y-intercept. And so below the y-intercept is this area on the left this time, down below the line. You can also kind of think about it if you're playing on a slide and this is the slide and you're hiding under the slide. You're less than the slide. Okay, here, same line, except it's a solid line. And then I'm going to shade below. Okay. All right, so what we're going to do now is we're going to do some examples of graphing. We're kind of doing the examples backwards order, but that's okay. So remember, the first step is you solve for y. If you have to move something and it's a negative, remember when you divide by a negative, it flips the inequality. Determine your M and B. Is it dashed or solid? And then shade the appropriate region. Okay, so what I'd like you to do is we're going to start off by doing these 5. Okay, so give yourself a second to copy them down, and we will go ahead and do them. All right, so here we're not going to get super technical graphs. All the graphs can be like little 2x2s. So x is -2. This is one variable. So when you have one variable, it's either a horizontal or vertical line. X is -2 on the left. This should be a dotted line, so it's a dotted vertical line. And this is the only situation when you're ever going to shade left or right, because I can't shade above or below. So the only time you're ever going to shade left or right is when it's an x. And so it says greater than, and my bigger numbers for x are on the right-hand side. All right, for number 4, I make a dot on the y-axis because it says y is 3. This time it's underlined, so it should be and it says less than. Less than is below, so I go below my y-intercept, which is all this area. All right, for number 5, I still would like you to find your m and your b. My m is 2, but again, it has to be a fraction because it's rise over run. So 2 over 1, and my b is -3. So I'm going to start at my b, my beginning, which is my y-intercept. So I go down 1, 2, 3, and then I count my slope up 2 over 1, up 2 over 1. That's probably good enough, 3 points. Now it's not equal to, so it's a dotted line. And we need to shade above because it's greater than. Now, it would be nice if all our problems were that straightforward, but you know that you're going to have some of these, like 6 and 7. So I figured we'd do 2 of those each. Okay, so for number 6, the first thing you need to do is move this 2x and we subtract it. So I get y is greater than -2x plus 5. So my m is right here, -2 over 1, and my b is 5. So I'm going to go up 5. And then I'm going to go down 1, 2 over 1. Down 1, 2 over 1. This line underneath, remember, that means it equals that also. So it is a solid line. And it says it's greater than. So greater than is right up here above the y-axis, above the y-intercept. So we shade above there. Okay, the next thing I need you to do is I need you to solve. Okay, hopefully you subtracted 3x first. So you get negative 4y is greater than negative 3x plus 8. And then I divide by everything by negative 4. And now here's the trick. When I divide it by negative, remember to flip. Oops, I didn't even do it. I said it and then I didn't do it. You need to flip this inequality. Negative 3 over negative 4 is positive 3 over 4. And 8 divided by negative 4 is negative 2. So my m is negative 3 over 4. And my b is negative 2. So that means I start here at negative 2. I'm literally out of paper, so I'm not going to be able to. Oh, I don't have to go down. I'm fine. So I'm going to go up 1, 2, 3, and over 4, which is way over here off the paper. I didn't give much space. Where's my pencil? So up 1, 2, 3 over 1, 2, 3, 4. So I know it's going to be this way. And usually I'm going to have you do it, but I literally ran out of paper. So I'm going to have to do it there. Okay, and I look at this. This is my equation I look at. And it says y is less than, so I shade below. Okay, so for all these problems, you had to start off by finding y. The first 3, they were already done, so that was nice. And then you have to graph it and determine where to shade. Now, sometimes you're going to have to find out if something's a solution. So there's 2 ways you can find a solution. The solution region is in the shaded region. That's why we've been doing all this graphing. So on this problem here, any number in this shaded region is a solution. So 3, 2 is a solution. 5, negative 1 is a solution. Negative 2, negative 2 is a solution because it's on the line. Points down here like negative 5, negative 1, that is not a solution. It's not in the shaded region. So there's 2 ways to find out if something's a solution. You can graph it and see if it's in the shaded region. Or you can plug in x and y and see if it is true, which means yes, it's a solution, or false, which would mean no, it's not a solution. Okay, so we have 2 problems like that to do, and these are actually number 1 and 2, so that's why I said we were going backwards. Okay, so give you a second to go ahead and copy these down, and then I'll go over them. If you think that you know how to do it, then go ahead and try it now, plugging in the x and y and see if it's true or false. So this is my x, this is my y. So I plug it in here. So it'll be 4 plus 3 is greater than 5. 7 is greater than 5. So this is true. So that is a solution. So over here, negative 2 plus 7 is greater than 5. So 5. Now it looks like it should be true, but 5 is not greater than 5, it equals 5. So it would have to have a line underneath it. So since this is false, this is not a solution. Same thing here, x and y. So it's 2 times 5 minus 2 is less than or equal to 8. Well, this is 10 minus 2 is less than or equal to 8. So 8 is less than or equal to 8. 8 equals 8, and this line makes it okay. So this one's a yes. And then here, x and y again, 2 times 3 minus, now y is a -1, so you got to remember to write that -1, less than or equal to 8. So 6 plus 1 is less than or equal to 8. And yes, 7 is less than or equal to 8. So this is another yes. So when you're doing problems like this, if you already have it graphed, then graph it. But if you don't have it graphed, I think it's much easier just to plug them in. Okay? So remember, when you're graphing problems, solve for y, flip the inequality if you divide by a negative, and then you need to determine the type of line and shade the appropriate region.